we're the air quality past and present team. My name is Mohammed. We have Quayne, Felix, and Amy with us today. So these are the contents that I'm going to cover today in our presentation. What if this was your reality? You have hazy skies, lower physical activities, weak response to diseases, such as lung-related diseases. We have cardiovascular disease, Alzheimer, and cancer. Well, this is turning into a reality for Stockton because Stockton has one of the worst air quality in the nation. As ranked by AAFA, it was 41st out of the 100 asthma capitals in the United States in 2023. There are a variety of explanations for this, but one of the major one is just discrimination for urban planning and proximity of schools and neighborhoods to industrial zones and freeways.
Okay, next, we'll discuss the significance of nitrogen dioxide in Stockton using NASA's Sentinel-5P satellite data. So why NO2? Well, NO2 plays a key role in atmospheric chemistry that can affect the lifetimes of greenhouse gases and is a pollutant that is detrimental to human health and ecosystems. Some sources of NO2 can be found from combustion through traffic emission or through industrial activities. So here, this graph here, we spatially averaged tropospheric NO2 and visualized elevated concentrations southeast of Stockton. The black border here represents the AB 617 boundaries. And in zooming in, we noted possible contributors such as the Amazon SMF3 factory, Highway 4 and Highway 99, or the Stockton Airport, which is not listed here, but it's located a bit further south. All of which contribute to high volume truck movement and is a significant source of combustion emissions, which leads us to propose that elevated levels of NO2 in the Southeast region are due to a variety of sources that can affect this Stockton community. I should also note that there are limitations in the accuracy interpreting this graph due to the pixel limits and when using Google Earth Engine and the lack of cloud filtering. This graph is also a monthly average of daily means, which is constrictive and more of a first step basis in analyzing NO2 over Stockton.
So in addition to satellite data, we now have expansive sensor networks that allow us to monitor PM2.5 at the scale of Stockton. But before we look at that data, we will need some scientific context to understand what is really happening, especially spikes that occur during winter months. So one big factor in this is meteorology, namely inversion layers. So inversion layers occur when cool air at the surface basically has a lid on top of it of warm air, because that change in temperature also leads to a change in density, which keeps those two layers from mixing. So any surface aerosols will be trapped there. This namely happens in the San Joaquin Valley because of the upwelling from the Pacific Sea. Basically, this warm air will be swept on top of the San Joaquin Valley surface air and will completely block it. And this notably occurs during winter months because a lack of radiation will keep those inversion layers from breaking because surface air will be kept relatively cool. And so here to the right, we have an extreme case of an inversion layer with surface pollution, which kind of shows that lack of mixing that can occur in a place like the San Joaquin Valley. So before we had all these expansive sensor networks, we only really had this one sensor, the Stockton-Hazleton sensor that is found in University Park. So right above the Crosstown Freeway. And this one is invaluable to get data basically from the last few decades. It's been collecting it since the 80s. But we have to be careful when trying to interpolate that data to the rest of Stockton, but it's still very useful to observe changes over long timescales. So here, for example, we can look at this graph, which shows some monthly data for multiple years since 2008. And we can already see those spikes during winter months for essentially all of those years. and we also see a general decrease in averages for more recent years. But what is alarming is this lack of buffering against potential spikes, like what we see in November for 2018. So while generally PM 2.5 levels decrease, there can still really be spikes because of either human behavior and emissions or meteorology. And now that in the present we have these networks, we can look at them in space. And this map shows both the potential and also the limits that our current Polar network has. So this is the annual averages for all the sensors around Stockton in 2023. And as a reminder, the federal limit is 9 micrograms per meter cube. And we see that there's a lot of variation, and this is really important to really address very specific problems for specific communities or households. But as it is, with the little data we have, because this is such a recent implementation, it is currently impossible to really interpolate it. So as the years advance, we will get more and more data, which will make these averages more useful. But this is still very useful for individuals or very specific communities to address their own problems.
All right, thank you, Felix. I'm going to go a little bit into the air quality complaints and enforcement data that we have. So the San Joaquin Valley Air Pollution Control District has the authority to enforce federal, state, and local laws regarding air quality. So what happens is that when they find like a business or an individual that's breaking these regulations, they'll issue a notice of violation. So the purpose of these NOVs is to initiate a corrective action that stops the violation from further occurring, and then to discourage businesses or individuals from committing more violations. There's a monetary penalty of up to $1 million per day per violation. If a certain individual or business is committing repeated violations or really serious violations that show just a kind of general disregard for the law or for public health, it can lead to criminal prosecution. On top of this, residents can also file formal complaints to the air district regarding air quality complaints such as odor nuisances and fugitive dust and things like open burning. And then these are then investigated by the air district. On this graph, we see the complaints submitted and the violations issued each year from 2017 to 2022. Knowing that all of these complaints are investigated by the air district, you would expect that there's some sort of correlation between the two. But despite this, we see this like huge spike in complaints filed in 2021, and it's really just not reflected over on the violation side, which indicates that the complaints filed somehow are not resulting in more violations being issued. On this map, we see the complaints filed from 2017 to 2023 within the AB 617 region. Out of the 156 complaints filed from 2017 to 2023, 61% of those, or 95 individual cases, were not confirmed. Our theory for this is that the time between the complaint being filed and then it actually being investigated is so long that the odor or whatever is there has already dissipated, and so the inspectors can't actually confirm that anything has happened. Our solution to this is to increase the number of inspectors or the priority of these complaints so that more of them can be verified before they disappear. Lastly, Mohammed's going to talk about our timeline and implementation plan.
So one of the first things that we need for our project is funding. So we would set up like task force to reach out to different apply for different research grants, and then try to enhance monitoring and engage residence partners with academics, advice, counsel. We can then craft policy and gather more inputs, and then advocate those policies to the local policymakers to maximize air quality impact. And then finally, we can evaluate our whole process and see if we can make any other improvements throughout the process. And finally, we can also partner with other global partnerships to overall contribute to this project. So this is our story map. You can go here and check ours. Thank you.